Am I on? Hello. I'm glad everyone decided to kind of stay for the last thing of the day. Hopefully it's interesting. My name is Jon Peppers, and I'm an engineer on .NET for Android and .NET MAUI. And so today I'm talking about a really weird thing, running .NET on the NES, and that means actually the Nintendo. So this, hopefully this will be a fun talk. Hopefully, I will have some assembly code on the screen, so hopefully we get through that, but let's get into it. Yeah. So this is what I imagine seeing this ad as a kid, and this is the first console I ever, owned or played or whatever, and it was amazing to me. You have this box and you can turn your living room into an arcade, and obviously to me that's great. And if we look at the specs on this thing, it's not too powerful compared to what we have today, right? Like an 8-bit processor, 1.78 megahertz. It can only do 52 colors and only 25 at once. And obviously the screen resolution and how much memory the thing has isn't very high as well. But so, I'm from Kentucky. This is a dramatization of me earning money to buy one of these things. And so I remember mowing my grandfather's yard and earning up to like $100, and then I had enough to buy this thing, right? And by the time I had $100, the Super Nintendo came out. So, and I wasn't going to save $300, but I just went with it. And the games were great. I mean, hopefully if you're here, you know what I'm talking about. Of course, the original Mario Brothers, classic, best thing to start with. And then the major upgrade, Mario 3, I would say is the next great one. Mario can now go backwards, which is I mean, it's great. And then, of course, Duck Hunt. This is one of those pictures that when I see the picture, I can hear the sound. I can hear that dog ridiculing me for missing all the ducks, So let's get into it. First of all, why would someone do this? We'll talk about that. I'll do a demo of what I have working. We'll talk a bit about the design I came up with and developer experience of what it looks like. I'll show you Hello World in C and C#, and kind of explain what an NES game looks like when you build one and run one. We'll talk about the binary format that is in an NES ROM, which you can load an emulator, or if you have the right equipment, you can flash it to an actual NES cartridge and put it in real hardware. And then I'll talk about how the whole thing works, converting Microsoft Intermediate Language to actual 6502 assembly. So why would I want to do this? Maybe I have weird hobbies. Maybe that's the main reason. But for me, I wanted to learn a little bit about computing history. I had maybe one college course on assembly, and my daily work, it seems useful to learn assembly code a little bit to just understand how the whole thing works. And of course, this is already what I work on, but doing this, you would learn quite a bit about .NET things like MSBuild, the build engine, not the conference, how to make templates, things like that. Also, I got in pretty deep learning about MSIL and ahead of time compilers, so we'll talk about what that means in a bit. And the obvious reason to do it is because it's a huge nerd flex to do this. Okay, so I should have listed that one first, maybe. But so another perspective on how small NES games are. There are only 512 KB that can fit on this cartridge, And I just picked a random stat, like the top iOS apps on the App Store. They're somewhere between 150 and 200 megabytes. And even the app icon of a general iOS app would fill up this cartridge. So not even the code, just the app icon would fill up this thing. Right? So let's demo, and I'll show you what I have working here, if this looks okay. So here I am in Visual Studio. Oh, it looks all right. I'm going to go, this is the new project template dialog thingy. I'm going to go into all project types. I'm going to pick NES. Do you think there's anything in? Okay. So I'm going to click on this. Let's see what it does. Yeah, hello. Let's call it like 𝗦𝗽𝗲𝗀𝗀𝗶𝗁𝗍𝗲. I don't know. Fine. So I'm doing this in Visual Studio, but you could be at the command line. You could be in VS Code. You could do .NET new NES. The only thing I've done to set this up is install the project template. But I'll open my program CS, which I'll explain this in a bit, but let's just go ahead and run it and let's see kind of what happens here. So it's building the project. Okay, whoa. Okay, so I basically just hit the play button, and this is an emulator. I didn't make this emulator, but this is one called ANESE, which I think it stands for Another NES Emulator. And the author was happy for me to use it for this project. And so, you know, this is what's working so far. And just to kind of prove that it's real, it's not like weird smoke and mirrors. Let's change a color. So that background color was blue, and like I was saying, it can only do a certain number of colors. It's not RGB, but I happen to know that the number 5 is a nice purple .NET color. So let's try that. And then let's just say, hello, Microsoft build. Yeah, okay. All right. So, yeah, it worked. Okay. And that's a pretty good build time, you know. A lot different than I'm used to doing Android and iOS things, and that's, yeah. Anyway, so let's look a little bit about the files. So I showed program CS. The other thing in here is you gotta have at least one set of image data, and that's what this file is. It's so short that they type out the bytes, apparently. But I have a viewer that we can look at what this looks like instead of weird letters. And let's look. So the project is just a regular .NET project, and all the magic happens inside of a single NuGet package. So we're able to just transform a .NET project into an NES project with this one line, basically. And then the emulator, I put that in a separate package in case I make another emulator work one day. That would give you some choice of which one. So I clicked Show All Files. Maybe we can zoom in just to show a few things inside here. So my project was Hello Buildy. Can we see that? There we go. That looks right. So the DLL file is what you would get from just building a class library. And the NES file is the actual ROM that you could take and load it in any emulator or whatever. So let's talk, that's pretty cool. Let's talk about how I did that. Let me get back to my slides. From current slide, all right, just thinking. Okay. So this is the part, it's gonna get a little hairy. I might have to put like assembly on the screen and talk about some things. But if you need to catch, you know, a little shut eye before the big celebration, you know, this might be a good time. So how did I even start like to think about doing this? I think step one for me was to focus on like the bare bones of what I could do to get it to work, right? So when I hit play in Visual Studio, there was not a debugger. Like you can't put a breakpoint. So ignore that part, right? There's no GC. The whole, .NET base class libraries, those don't work. You can't write classes or even methods. But this was really just, can this work at all is kind of where I was starting from. And because this is for fun, right? This thing is not a product, to be clear. I'm not selling this. It doesn't have to be compatible with anything, basically. So I focused really on the hello world at first. And a lot of times something like this is when you get hello world working, that's like, oh, that's what I needed to like really get things going and get motivated to do it. And of course that workflow I showed, .NET Build, .NET Run, that was really the part that I wanted to start with. So how does this work? You've got the C# compiler, and we've got some code. I'll talk about what the code does here in a bit. And this part remains unchanged. Roslyn builds this library like it would any other library. I've turned off a setting that doesn't allow the standard libraries. So we at least have that going for us. And then this is a view of 𝗦𝗲𝗀𝗶cie, which is a great tool. That's what I use to like debug what happened when we built this project, what's the output. You can view C# code or IL, and this is a kind of a picture of IL. And then the next step is to write an MSBuild task that can convert this IL into what the NES understands, which this is a screenshot of 8bitworkshop.com. So this process sounds a little familiar. If you know about .NET, we have the just-in-time compiler. And even since .NET Framework like 1.0, it loads MSIL at runtime as each method is called on the first time. And it does this process, right? It takes IL and turns it into machine code that can run on the computer that it's running on, right? And so another thing I'm familiar with, so Mono has an AOT compiler that does this step at build time. So this is basically exactly what we're doing here for the NES. And what's interesting about the AOT compiler, we used it in Xamarin. We still use it in .NET 8 and .NET MAUI. And on Apple platforms like iOS or Mac Catalyst, it's not actually possible to run a JIT. And so this is a requirement on those platforms. And so, Apple documentation might say something like, this is a security feature, but it also gives faster startup, which is good in general for mobile apps, right? And lastly, we have a new AOT compiler called Native AOT. This came out in .NET 7 for console apps, which is already pretty useful. If you're writing a little tool, I'd recommend looking into this, like some kind of command line tool. In .NET 8, they added even more support. So I think they added some kind of ASP.NET experience, but we also have experimental support for iOS in .NET 8 for native AOT. And we're going to have more coming in .NET 9 in the future. So 8-Bit Workshop. So I'm not affiliated with them. I'm just a fan. But this is the tool I use to even figure out how to do this at all. It has not only the NES, but there's a drop-down that has all kinds of old machines and emulators that you can write programs for in the browser. And so you can write C code in the middle here, and then there's an emulator that just runs live, and you can actually put breakpoints and see the disassembly and see what's going on. So this is invaluable in figuring out how to get this to work. You could also, once you've got a project working, you can download the ROM just like I created in the other project. So let's go through Hello World. This is what the code looks like in C. So you have a void main. And this is really kind of the minimum to get something working. The first method, pal_call, is palette colors. And so that just sets up the default colors on the NES game. And then we have a VRAM address call and a macro called nt_address_a, well, which the names, they're a little abbreviated back then. But what this is doing is moving the position, maybe you can think of it as the cursor. We're moving over 2 pixels and down 2 pixels, and then we're drawing the word hello world. And so we also have to pass in the length of hello world, so that's what the 13 is. And then PPU on all turns on the screen. And then lastly, you have to have an infinite loop for the game to stay running. So in a real game, you would actually have code inside the while loop, but for a demo, you could just while true basically forever. And what would happen is if that loop exited, that's what it would be like when you've seen an NES game crash. And so my memory is a weird noise, and then the whole screen is frozen, right? And I think that's basically the behavior that you would get if you exited out of that loop, which would only happen on some kind of fault, right? So what could we do in C#? So one of my goals here was to keep it looking the same so that if you're looking at a tutorial in C, you could do the same thing in C#. With the idea that one day maybe I could come up with some API to make this look even prettier than what it is today, right? And so we could use top-level statements. The latest C#, you don't have to have a static void main, so let's just use the one program CS. Those methods up there, that's actually a static method on a class. And I'm using implicit global usings to just make this look like the C program. And of course, using static to be able to automatically call those static methods. So now let's talk about like my thought process in trying to simplify this even further, right? The code I showed there is from a library called NESlib, which is, you could use that to write games, or you could write the games in pure assembly code if you would rather do that. But NESlib, where I started is just take the header file and paste it into a C# file and just kind of make that valid C# and get a reference assembly of that API surface. So that when you go to build the project, it doesn't have to actually have method bodies for that code. It can just be a reference assembly and show which code it would have been called if it was a real .NET program. And so, of course, we need a project template. We're going to have MSBuild tasks and targets, which I'll talk about a little bit. And then we kind of get into the details of what is the NES binary format, and how do we write that in C#. I also wanted to, at first, understand just enough to be able to change the text on that one instruction of hello world, right? Because in my mind, if I was able to change that text, that would motivate me to finish this thing. And then I'll use a library called System Reflection Metadata, which is part of .NET. This is also similar to mono.cecil, if you've ever looked into something like that, opening .NET assemblies. And you can use this to iterate over IL and do something with it. And in this case, we're going to convert it into assembly. So I also wanted to convert multiple samples. So I have a few working. And then eventually the goal is to write Super Mario in C#. I don't know if we'll get there today, but maybe someday. So let's talk about the file format. So at the very top of a NES ROM, there's a header that's like 16 bytes. And then there's a trainer, which I'll talk about in just a sec here. The PRG ROM, which I assume stands for Program ROM, is where all your code lives. And so you can have a few chunks. Most of the samples I have 2 of these 16 KB segments. And then a single CHR ROM, or which I might call it a car ROM. I don't know if that's character ROM. Sounds good. But games can have more than one of these as well. So if you're Mario and you go to the underwater level, they're probably swapping from one of these sprite sheets to the other to get those underwater sprites. Because it does not look like that you could fit the whole game onto one. So the trainer. The trainer is very interesting. So developers back in the day when they're working on an NES game, let's say that you're working on Bowser's castle boss fight. Do you want to play the whole game to get to that level? Not really. So the point of the trainer was so that they could put feature switches into the game during development. So like they might have Mario be invincible. He has the star at the beginning. Or maybe you just boot the game and it goes directly to level 8 or whatever. And so that's what the trainer was used for. And one interesting product is the Game Genie, which took advantage of the trainer. So the trainer is not physically on a card. So if you have a copy of Super Mario Brothers, there's no trainer in it. But what the Game Genie did is you would attach it onto the cartridge and put that in your NES, and they reverse engineered all of these feature switches in all the games. And so the Game Genie, it had a menu where you could pick, oh, I want to be invincible, and you would turn it on, and then it would boot the game, it would launch the trainer, and you're playing the game in developer mode, basically. So that's kind of a fun story. So if you popped open a cartridge, one of those gray NES cartridges, this is the board inside, and it has those same letters, CHR, PRG, and that's all the space you have, right? Your game has to fit in those actual chips right there. There is an ability to add expansion slots, but we're talking like, oh no, like maybe we can add another 128 KB, like not very much. And so the header, what it is literally the letters NES, followed by end of file character, and then a couple of bytes that say how many program ROM and character ROM segments are on the cartridge. And so the flags also would, I think maybe byte 6 is if there is a trainer or not. And so that would be something the Game Genie would have toggled to make this whole thing work. And the rest are zeros for some reason. So if you wanted to write an NES header, you could just, so the writer here is just a system IO binary writer, and you can just write bytes as you would expect. You write NES, the end of file character, the number of segments of the two pieces of data, and then the rest zeros. And so when I first got this working, I had a unit test that called this code, compared what I wrote against a real ROM, and then when it actually worked, that was kind of, a light bulb moment. So let's look at the character ROM. These are two different programs of the same image. There's a lot of different editor tools for looking at this. And the thing that's interesting is that colors of the image are not, they're dynamic. So each tool might choose to display them a bit differently. So one of them has red letters and the other one black. Because when you draw these, you can tint the colors. And that's how they were able to make games with much fewer actual artwork. If you've played Mario 1, the clouds are white, and you turn them upside down and they're green, and now they're bushes, right? So all kinds of tricks like that are in the old games. And this is just the default sample sprite that it was on 8bitworkshop.com, but it has a font, basically. So any ASCII character is the first part of this image. And then the bottom is what you have left to use in a level. So that's pretty interesting. So let's talk about the instruction set just briefly. Don't worry about reading this, but this is a table of every instruction that the NES can do. And the thing to note is there's actually not that many. It was kind of a simple machine. Some other older computers have this same instruction set, so like the Apple II, some Commodore machines, and I don't think the Commodore 64, but like some other Commodore machines use this same instruction set. So it's kind of a, well-known 6502 assembly is a thing that people have known in the history, in history. So if you looked at the instruction set that's in MSIL, so .NET assemblies, it's actually a much larger table than what we see here. So let's talk about, this is going to be a little pseudocode, but this is what it would take to kind of fake our way and make this work, right? This is my thought process in the middle of this project. So now imagine my writer is not a binary writer, but an NES writer, and I've subclassed binary writer. So we know how to write the header. That part works. And then I'm just going to ignore a bunch of bytes. And so what I did is I took a slice of a ROM that worked and just saved it in my own file to think about later, right? And then I figured out how to write a single method call, which is that VRAM write call with the text hello. Another segment of bytes that I don't know, right? We'll call that segment 1. And then a string table. So the VRAM write call, it doesn't have the string there. What it has is an address that can look up the actual string data in a table that's at the bottom of the ROM. And then, of course, there's one last section of unknown bytes. But this was my starting point, right? Once I saw this work, I was ready to keep going. So let's look at the .NET side. So this is a screenshot of 𝗦𝗲𝗀𝗶cie, which is still my favorite tool for looking at assemblies. And you can look at all the C# code inside. So there's a tree view. You can open the namespaces and see what's inside. And the code that you'll see in there is backed by these tables that are under the metadata folder. So for example, there's a user string heap, which is what we're mostly interested in. And that'll contain any strings that are in your code. So like any just constant string like hello world that's in the middle of your C# code will be in this table. There's also a string heap, and what that will contain are actually like class names, method names. So the string heap is more about actual C# names of members, while the user string is more like inline strings that are within your code. So what it looked like to load IL, this is using system reflection metadata, and it is kind of a modern version of mono.cecil. And one of the things it's really good at is being fast and not allocating unless it has to. So on the second line here, the var handle is actually a struct. And that's why the while loop looks a bit weird. Checking handle is nil, a struct can't be null, and so they have a property to check if the struct is empty. So while you're looping through the strings, it doesn't actually allocate until you call get user string, and you give it a handle to a row in the table, and you get the actual string value. So if we call the writer and we pass this string in, what you can imagine what that write string method does is it just calls encoding ASCII get bytes and just writes those bytes to the underlying stream. And then there's a 0 byte between each string. So that part's kind of straightforward. What about the actual method call, right? This is kind of what the code in 𝗦𝗲𝗀𝗶cie looks like, but there's a C# view and an IL view. And the numbers on the left are just like the offset within the IL. You could probably ignore that. But then there'll be an instruction, like in this case, load string, which based on the instruction, it may or may not have an operand. And in this case, it has a single string value, hello.net. And then the second instruction, so one method call to us in C#, we would imagine that that's just one thing, but it's actually two. for each argument in a method call, it puts them onto a stack and then actually calls the method using the parameters that are on the stack. And so then the call operation calls the actual method. And this method is actually in another table. So even in an IL, everything is based on tables. So this is what the same, so we just looked at the IL. This is what it would look like on the NES side. And for me, I did not, even now, I don't really know 6502 assembly. All I did is kind of write unit tests, and do I get the same output? Which, that's a good way to go, I think, right? So, I mean, and anyway, so the blue letters on the left, those are the actual bytes. So the number A9, if you opened an NES ROM in like a hex editor or something, and you went and found this byte, the letter A9 means the instruction LDA, which, who knows? I don't know what LDA is. Load address. And then F1 is the actual operand for that instruction. So one thing that's interesting is the NES is only 8 bits. So what do you do if you have a number that's bigger than 255? And so, in this example here, we see what they do is they have to put part of the number onto a register, right? So the address for VRAM right, actually it's the string table, is bigger than 255, and so it calls a subroutine named push AX in order to make that math happen, right? And so JSR is jump, subroutine, and return, I believe. And so you could see where if we go back to the IL, it's reasonable that we could generate this code, right? And so here's what it would look like to do that. On my NES writer, I've created an enum for every instruction. And then you can pass in an operator if it's a single byte, and that makes it to the underlying stream. So some of these, here for example, the call to push AX, it's bigger than 1 byte. And one thing that's interesting is you can see that the numbers are flipped around, right? And the reason for that is the NES was a little Indian machine where the smaller parts of a number are first, which is a bit odd. I think that's backwards from like Windows and maybe some of the other operating systems maybe we're used to. But anyway, so this looks straightforward, at least writing these bytes out. And so the next step for me was to, again, get all this code working, unit test, check that I can emit a ROM that's byte for byte identical to one that was written with other tools. So I got that to work. So let's talk a bit about MSBuild. Does anyone here know anything about MSBuild? Is it okay? Yeah? It's kind of like defense against the dark arts for .NET developers. It's a love-hate thing. But it's if you have the skills to use it, at least to like read a log, that really saves the day when your build is broken on a random day. So this is actually kind of the stuff I work on in my day job, but MSBuild has kind of 2 concepts. There's targets that are written in XML, and then there are tasks that are written in C# generally. And so a target, so I have a target here named transpile. I'm not a huge fan of using that word, but that's what I put. It runs after the build, so the regular .NET build is done. It has an input of target path. And so anything in here with a $sign is how you reference an MSBuild property. And so the input would be, for example, hello DLL, and the output would be hello.nes. And the way targets work is if the input is newer than the output, or the output doesn't exist, it will run the target, and otherwise it'll get skipped. And so this is just general good practice for writing MSBuild targets. And then I have a task here, transpile to NES, that this actually is C# code that does the work to make this happen. And I pass in the files that are needed. At NES assembly, that's actually an item group, which is different than a property, but an item group you can think of as a list. And so you can have more than one .s file, and this would still work, theoretically anyway. Yeah. And so how do you launch an NES emulator? This is kind of what this is actually even simpler than writing a target, but it's just setting a few properties. So .NET Run, it understands if you set the property run command to something and run arguments and the working directory. And when you call .NET Run, it'll evaluate your project and just call these commands just as you filled them out. And so that's how I'm able to launch an emulator and do custom things during .NET Run. And Visual Studio understands the same thing. And so you don't actually have to do any extra work to make this happen. So this might be useful if you have other types of projects, like let's say you had a project that runs some scripts, you could use this same idea for that as well. So the next step, let's talk about, I have these pieces of bytes saved in files at this point. I want to get rid of those. Because to me, that's not really doing the real thing, right? I want to write the whole NES binary end to end, and that is where I consider, oh, it really works at that point. And so NES lib, that first set of bytes is actually all of the implementation of NES lib. And so we could take one of those methods that are in the Hello World example, palette color, pal call, and this is the actual implementation of this subroutine. And so just in the same way that we wrote the other bytes before, we can use the exact same writer class to write out these bytes. And this is pretty straightforward. There are some instructions like TAX here doesn't have an operand, so this is at the point where I would discover how some other instructions actually work, was when I got to this far. And there are only about 44 methods, so it was a bit tedious, but this is something I was doing with my spare time, right? So let's talk about where it is today. What I showed you today, how much of it really works. This is a second sample that was, what this is showing is all the things that you could do with a single piece of the character ROM on the image. So this is a single little, I don't know, rhombus, whatever. And you can tint the color, various colors. And this is just an example showing how to do that. And this sample had some other interesting things in it. It had some inline byte arrays that set up this data. And so there was some work to get this one working. A couple samples are working today. And I'm generating the entire NES binary, and I don't have any pre-stored sections of bytes anymore. There is one, I'm pretty sure there's one to-do comment, there are 4 bytes that I never figured out, right? So it says, to-do, I have no idea what these bytes are, right? So, but it does match what real ROMs have in it, so it does work. At the point I have this today, it's probably not gonna work to build a real game yet. That's something, I can keep working on it, maybe something in the future. But for now, if you wanted to learn more about NES development, I would recommend just using 8-Bit Workshop and learning a bit of C. And there's other development tooling out there that also can do things in kind of a graphical way. And so, some things that I would like to do, more complicated branching, like a switch statement or some strange combinations of if, else. Maybe those wouldn't work today. I'd also like methods to automatically be subroutines. That would be another a great thing. And it also would be possible for structs to work, would be the next thing I would look at. So, but one day, maybe we can get Super Mario Brothers in C#. We actually may not be able to do this because the game is not open source, right? So it's also one of the first games, and so it was actually written in pure assembly. So that might be a little tricky. But what I thought that does exist, there is likely a open source Mario-like game that we could probably get working one day. So if you want to try it out, the project is on my GitHub. It's github.com/JonathanPeppers. You probably find it. If you just want to play with it, you can actually just type .NET new install, and then the name of the template packs, which is .NES.templates. And I called the project .NES. I don't know about the name. Maybe that's okay. I don't know. And I have an AI-generated logo that's also not great, but maybe we could work on that as well. But thanks. Yeah, I mean, that's all I have. Yeah, I hope this was enjoyable. And I hope you have a good rest of the build. Yeah, so. But yeah, I'll be around for a bit if you want to come chat or you want to pump me up and get me to finish this thing. You know, I'm happy to talk about that. Thank you.